I am in an extremely good mood because TSM just won against C9. Today's lesson not going to be that hard. It's stuff that you should already know. I say that for every lesson, but this is stuff you truly should know. Why is there no one here? It's like, how many people are here? There's only 7 of us? Okay. I guess I might as well just get started. All right, so yeah. So today's going to be a bit of a mixed bag lesson today. We have a lot of stuff going. Order of operations, you know order of operations, a little bit of arithmetic, composite numbers, basically non-prime numbers, divisibility rules, and a little bit more. So let's get started. All right, so let's learn exponents. So you guys probably know what exponents are, but I don't know if you guys know exponent rules, like the rules for exponents. So I'm gonna teach you guys that today. So if you don't know what an exponent is a number that tells us how many times a number called the base is used as a repeated factor. And so the base is the number that's used as a repeated factor. So example, 5 cubed. So this 3 right here, we call it 5 cubed because of 3. Instead of 5 to the 3rd power, I'll talk about to the something power later, like a couple bullets down. But this is 5 cubed because of 3. So whenever you see something, so let me, when you see something to the 3rd power, x to the 3rd power, this is x cubed. When you see something to the 2nd power, like 5 squared, that would be x squared. So you see something is squared when it goes to 2nd power. Everything else, you say by like 1st, 4th. So x to the 1st power, you don't even say x to the 1st power, you just say x. X to the 4th power, so you just do it by order, but cubed and squared, 2 and 3 are just different. If you didn't know that, you probably already know. Okay, and keep in mind that 5 cubed means 5 times itself 3 times. Not the same thing as 5 times 3. You guys probably know that obviously as well, but I've seen a lot of people make that mistake when I was a kid growing up, and a lot of people still make it a mistake in my age group. So keep that in mind. It's not the same thing as 5 times 3. It's 5 times 5 times 5. 5 times itself 3 times. So 5 is the base. So the big number is the base, and 3 is the exponent. You guys know that? And you say exponents, you say a to the nth power. So a to the nth power, like that, right? Where a is the base, right? And n is the exponent number. And unless n is 2 or 3, then you would say based on its 1st, 4th, 5th, 19th, 27th, blah, 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 right? So only 2 or 3 is you don't call it. So example, this is 100 to the 120 to the 7th power. So 120 to the 7th power. And this is 76 to the 12th power because the 12 is 12th. So yeah. All right, so this is a quick problem. A GameStar received a shipment of puzzles. The boxes are stacked in 6 rows with 6 boxes in each row, and each box has 6 puzzles. What's going on? Puzzles. How many puzzles are in the shipment? So this is really simple. You see 3 numbers. So you can make an exponent off this one. There's actually no one here today. 1, 2. There's only 9 of you guys. Wow. So give you guys a couple minutes to do that. Should take you like 10 seconds. I need some water. I'll be back. Okay, back. Okay, yeah. This is pretty easy. So this is just simply 6 times 6 times 6, which is 6 cubed, or 6 to the 3rd power. It's a bad equal sign. So since there are 6 rows with 6 boxes, that makes an array, right? You're 2 off, Jenny. 2 off. That makes an array, and we can do 6 times 6. But then each box has 6 puzzles. I say in this next bullet. Yeah, there you go. Switch the 2 and the 1, Fairwin. Okay. So since there's 6 puzzles in each box, in this array 6 times 6, you have to multiply by another 6, so it's 6 times 6 times 6, which is 6 cubed. So there's 216 puzzles in the shipment. There you go, Fairwin. Yep. And I can do it out. So 6 times 6 is 36. So 36 times 6 would be 216. And I'll just do it out real quick. If you don't believe me, So this is a 6. That becomes a 3. 6 times 3 is 18 plus 3 is 21. So you have 216 right here. Typo. Okay. That's good. So yeah, easy enough. All right, here are your exponent rules. Do you guys know the exponent rules? I think you guys do. You should know them once you get into middle school, or what they call it internationally, secondary school, I think. Primary school, secondary school. So you should know it. So first one, I like using X and M and N instead of A and B, but I'll just follow this. This is really good, by the way. All right, first rule. Anything to the 0th power equals 1. So 2 to the 0th, 1. 100 to the 0th, 1. 0 to the 0th, that is special, actually. That is a little special. A lot of people say 1. Some people say 0. I think it's actually equal to 1 if you put it in the calculator. Let me check right now. So 0 to the 0th is actually special. Actually, no, it actually gives you an error. It says 0 or 1. So don't do 0 to 0th. But anything else that's besides 0, that's why it says non-zero real numbers, is equal to 1, right? So as a rule of thumb, x is 0 is 1. Okay, rule number 2. Negative property of exponents. So like you said, you asked about this yesterday, Jenny. Negative exponents aren't that bad. So basically, when you have a negative exponent, you just take the reciprocal of the exponent. So b to the negative n power is just 1 over b to the n power. Or likewise, 1 over b to the negative n power is the reciprocal of b to the negative n. So yeah, it's not that bad. So if I had x to the n power, negative n power, be 1 over x to the n. You just take out the negative. It doesn't make the number, it doesn't make x negative. It doesn't make your answer negative. It just makes it a fractional component. Yeah. So when you multiply something, so like say you multiply a times 10 to the negative 27th power, this is really small because this is 1 over 10 to the 27th, right? So yeah, and I never see it in this form. No one ever writes it like this, but just keep that in mind because this is the reciprocal. This is the exact definition of reciprocal, 1 over a number. So 1 over b to negative n. So yeah, tiny. What is the n power to the negative n power? Oh, n is just any number. So m and n are any integers. Decimal exponents are a pain to do. You can only do them at a calculator as far as I'm concerned. So n has to be integers. And we all know what integers are from yesterday's lesson, unless I went over that too fast, which integers are basically 1, 2, 3, 4, 5, or -1, -2, -3, any counting numbers. All right. Product property of exponents. So when you multiply exponents with the same base, you have to keep in mind they have the same base. You just add the exponent numbers together. So if we had 2 squared times 2 to the 3rd, 2 cubed, that's just 2 to the 5th, right? You can check it yourself. I'm not going to do it, but 4 times 8 is 32, and 2 to the 5th is 32. So you can check it yourself, but trust me. So that's how it works. Now notice if you didn't have the same base, so if you had 3 squared times 2 cubed, you cannot simplify that without manually simplifying the exponents first, like as numbers. So this is 9 times 8, which is 72. So you can't necessarily simplify that further. As like in this one, since they have the same base, both have 2, you can. All right, 4. Quotient property exponents. So when you divide exponents with the same base, remember same base, you just simply subtract them. And yes, you can have negative exponent answers. And that makes sense, right? Because look at this. So if we had 2 to the 4th over 2 to the 3rd, this is the same thing as 2 times 2 times 2 times 2 over 2 times 2 times 2. Now these 3 2's cancel each other out, and you're left with 2 to the 4 minus 3, which is just 2 to 1. So that's how it works. That's why it works. Can we solve negative exponent fractions? What do you mean solve? Like solve an equation using negative exponents? You can do that. No? What do you mean solve then? Can we find the answer to them? Because you can, yeah. So I don't know what you mean by solve. But yeah, basically when you divide exponents with the same base, remember same base, you just subtract them. Yep, that's right, Zoe. 2 to the 5th is 32. Okay, negative exponents at the numerator and denominator. Oh, I see what you mean. Then you just flip the numbers, right? I see what you mean. Okay. So I'm gonna clear everything here. So if you had you just flip the numbers then. So if you had 2 to the negative 4th over 2 to the negative third, you just flip it. So this is 2 to the third over 2 to the fourth. Because this will go on bottom and this will go on top per this rule right here. No, wrong rule. The other rule. This rule. Is that what you're trying to say? Because you can do that. And it's the same thing as subtracting it. Yes? Okay. I think, yeah, it's the same thing as subtracting it because look, because -4 minus -3 is the same thing as -4 plus 3, which gives you -1. And it's the same thing right here because this is right here. 3 minus 4 is -1. So you get the same answer. So yeah, this rule still applies. This rule still applies. Just a general good things to know. So yep. So far the most common rules are these two rules, number 3 and 4. Number 2 is like a given, like everyone should know it. And 1 is just easy. It's like anything to the 0th power is 1, except for 0. 0 is special. All right. Number 5, this is easy. So if there's a power to a power, which yes, you can do that, b to the m power to the n power, you just multiply the exponents together. And yes, you can do that. So 2 to the 2nd power to the 3rd power is equal to 2 to the 6th power. And you can check it yourself. 4 to the 3rd is 48, and 2 to the 6 is 48. And you can check it yourself. So yep, it's pretty simple. So when you have a power to a power, you just multiply it. All right. Power of product property of exponent. I've never learned this rule. Oh yeah, no, I know this rule. Okay, so you can just basically distribute between two different bases. You can basically distribute the exponent out if they're multiplied together and the entire thing is multiplied. So this is just a to the m, b to the m. What is 2 power to the 3rd power? So you can take a power of a power to the power of. So you can stack powers. And basically, here, I'll just erase number 6. I'll go back to number 5 real quick. How? You just write it that way. I mean, if you wanted to do it manually, so if you had 2 to the 2nd to the 3rd, right? If you want to do it manually, what you do first is 2 to the 2nd first. So you get 4, and then you keep the 3rd, and it'd be 4 to the 3rd, which is 48. How do you solve it? Yeah, you just do the inside first. So 2 to the 2nd first, and then you take whatever answer 2 to the 2nd is, which is 4, and then you keep going up this way. Just keep going up. Okay, yep. But it's much easier just to simplify it as 2 to the 6. So much more simpler. Because, you know. Oh, it's 64, you're right. Whoops, whatever. You're right. I was thinking, yeah. It's 64. Whoops. Thank you about that. Thank you. 64. I'm excited. TSM is going to Worlds, guys. I'm in a really good mood. TSM is finally making the Worlds after 3 years. If you don't know what that means, that's okay. Anyways, let's move on. All right. So rule number 5, I never see it like this, but I guess, because usually what you just do is just simplify the parentheses first. But I guess if it's 2 variables, so x times y instead of a times b to the n power, you say x to the n times y to the n. But notice you can't simplify this using rule number 3 because they don't have the same base. Assuming x and y are not equal to each other. What TSM, whatever, don't worry about it. Okay. So you can't simplify it using rule number 3, product property, because they don't have the same base. So keep that in mind. And unless conditions say x is equal to y, which then you wouldn't even write this in the first place. You just say this is x squared, and then you would have, it's not equal to, but then you have x to the 2n power. So yeah. Okay, number 7. Oh, power quotient. Okay, power of a quotient property exponent. It's the same thing, same concept. X over y. You just distribute the exponent out. This is m, x to the m over y to the m. And yeah, you can't simplify it, assuming that x and y are not equal. You can't simplify it because they don't have the same base, but you just distribute it out. And I don't have any practice problems for you guys, but this is good. How do you solve it? You just do it. So let's say x was 2 and y was 3 and m was 2. All right, so this would be 2 squared over 3 squared, and you just do it. 2 times 2 is 4 over 3 times 3 is 9, so it'd be 4/9. That's how you solve it. You just do it. You just do the exponent. Remember, so the definition of exponent is just multiply the number by itself, how many times the exponent is. So this is 2 times itself 6 times. So 2 times 2 times 2 times 2 times 2 times 2. It's 1, 2, 3, 4, 5, 6 times. All right. Any questions? This is stuff you guys should know. I don't have any practice problems with you guys for this one, but you definitely 100% should know this. Or you could do 6 times 6. Yeah, you can do that too. Yep. Okay. And yeah, so memorize these. These are very important. Most important is 3 and 4. Like I said, 1 is a given, 2 is a given. Like you should know that top of your head. 5 is pretty nice to know. 6 I don't see very often, and 7 is very nice to know. So memorize 3, 4, and 7 the most. 5 and 6 are good to know, and 2 and 1 are like givens. Like you should just know them right at the top of your head. All right. Adding and subtracting decimals. You guys know how to do this. I took this off Khan Academy because maybe you might not know, but it's really easy. So it's like adding and subtracting whole numbers. It's the same thing. You just match up the digits with their place values and just make sure you line up the decimal places. I mean the dots, decimal dots, decimals. So you have to consider matching up the decimal place values. And they start with tenths, obviously. So tens, hundreds, thousands, you guys know that? There's no such thing as ones, obviously. And when you add and subtract decimals, you line up both numbers' place values in the right spots. So example. Well, actually, do you guys know how to do this? You guys need me? Okay, I'll do number 1 with you guys. So if I had 122.354, right? Plus, now notice how this has 4 digits out here, right? So I can add an extra 0 and it'd be equivalent to this 122.354. If I just add 0, I can add infinite amount of zeros and they would be equivalent, right? That's how decimals work. And so what I want to do is I want to line up these 4 digits. So I have the 9 here. Then I put the decimal point that comes after. And then put the 1, the 2, the 8, and the 5. And just add it up normally. So 5, 4 plus 8 is 12. So 5 plus 2 is 7, plus 1 is 8. 3 plus 1 is 4. Then you just bring down the decimal point. 2 plus 9 is 11. 2 plus 1 is 3. And that should be your answer, 131.4825. So I think this is just you guys do this on your own, because I think if I click again, the answers will be shown. So yeah, give you guys a couple minutes to do that. And you don't have to have these zeros. There. Actually, I might have to do number 3. Let's do number 3 real quick. Okay, so if you don't know, I'm sure you do know. Add the 0 right here. So sometimes you may need to borrow from the 7 because the 0 right here. So if you didn't know, because if you have a lack of digits on the top number, you can borrow from the next one and this would become 10, right? So 10 minus 3 is 7. 7 minus 1 is 6. That's 2. This is 3. And that's it. 0. You know how to write that. So 3.276. So just in case if you don't know, which you guys do know, because you guys, I know you know. I know you guys know. Did you add number 3, Zoe? I think you added number 3. Yeah, you added. That's a subtraction sign. Yeah. Yep, I'm getting a lot of good answers, a lot of correct answers. Ah, I see. Everybody joins in last minute. I see. Now there's more people. It's like 20 of you guys. Except there's 3 Donalds. Way to go. That's a pog moment, dude. 3 Donalds. Poggers. Zoe, you're adding number 3. I mean, that's right if you added it, but this is 17.28 minus 14.013. But yeah, if you read, yeah. But if you added it, that'd be right. That's the right answer. If you added those 2 together, I think. Yeah. Close. Not as close as. Hmm. I guess do it left to right, Joseph. I think you're trying to. Yeah, do it left to right. Oh yeah, huh? Okay, how I learn is that I'll get into this later, PEMDAS, but I know it's PEMDAS because addition goes first, right here, addition's right here. But I learned that if you take these 2, just group them together, you do them left and right. And if you punch in a calculator, that's what it does. And I learned that traditional as a kid. So do it left to right. So do this first. So do this and then add this. I know addition is first here, but I learned that you have to group these 2 together. And then, yeah. But you would be right, Joseph, I guess, if you strictly followed PEMDAS, I guess, because addition does come first. But I learned it where if you just have those 2 operations together, you do them left and right. Yep, that's right, Zoe. All right, let's move on. I think we're good. So you go. This should be a 5. That should be a. Oh, I didn't put the 9 here. Okay, this is wrong. 5705.069. Did I do these wrong? Oh, I must have changed some of these. Okay, let me check these. Hang on. Oh, that's right. Okay, that one's right. That's right. Yep. Okay. Yeah, close enough. All right. You guys good? You guys good? Yeah, so just line up the decimal places. You guys know how to do this. Line up the decimal places. Add any extra decimal slots if you need to. Any zeros. And yeah, that's it. All right, multiplying decimals, easy stuff. Same thing. It's like multiplying regular numbers. You just have to. I learned that you pretend the decimal point is there, but you can put you can keep the decimal point in when you're multiplying it. Okay, so I'm gonna skip all this. So all you want to do is just basically take your 2 numbers, right, and figure out how many decimal places are there, right, together. And then when you find the product, you just simply move the decimal point to the left based on how many decimal places in your factors, basically. So this one, so for example, 3.63 times 1.4, there's a total of 2 plus 1 decimal places, right? Yeah, I'll show you what I mean. I'm not going to read this. I wrote all this. You can read it yourself. Here, I'll erase this. You can read it yourself, but it's not really that good if I don't explain it out loud. So what I mean is that you take your 2 factors and notice that there's 2 decimal places in 3.63 and there's 1 decimal place in 1.4. So for a total of 3 decimal places, right? Decimal places. And all you just do is just multiply it out, right? Did I multiply it out? Okay, yeah. So first notice that I total of 3 decimal places. Yeah, keep going. Okay. And so you just multiply it out. So you could ignore it. You could do this 363 times 14. You could do that, right? But you don't have to. You just keep it in. They don't really distract you that much, right? And a tip that I usually like to do is whichever number with more digits will go on top to make it just look easier. Can you explain that for the last slide? Okay. Okay, so what do you want me to explain? So it's like the same thing as multiplying integers. It's like same thing. Honestly, it's really the same thing. So there's 2 decimal points. How to do it? I'm explaining it right now. Yeah, I'm explaining it right now. So there's 2 decimal points in 3.63. There's 1 decimal point and 1.4. So there's a total of 3 decimal places. So keep that in your head, right? Keep the 3 decimal places in your head. And then what you could do is you could ignore the decimal places, right? And just pretend they don't exist anymore. So you do 363 times 14, right? And like I said, for a tip, number of more digits go on top, just to make multiplication easier. And just simply multiply it out. So you get 5,082, assuming that there are no decimal points. And so what you do now is that you count 3 decimal places, because remember, you memorize that in your head, the 3 decimal places, and you just count it from the right, you just count it left 3 times, right here. So your answer would be 5.8 or 5.082. That's basically it. So it's basically just multiplying like whole numbers. Same thing. I mean, you guys know how to do this, right? Why do you have to move the decimal point over? Because you're multiplying it out. Because you're multiplying out the number of places. You have to add an extra place. Because when you multiply it out, there's actually a lot more digits involved, and the place is over. So you have to move it over to keep the decimal place. Because if you didn't, then the answer wouldn't be the same. 363 times 14 is not the same as 3.63 times 1.4. So that's why you have to keep it the same. What if you kept the decimal point? Would it be the same or moved? If you kept it, it wouldn't help you much because usually they'll be in different spots. So if I had 3.63 and 1.4, you have no idea which one to move down. So you can keep it, but then you just have to ignore it then. And you just have to focus on how many places in total. Keep your answer. Which one do you move down? That's exactly what I'm saying, Cindy. Yep. Exactly what I'm saying. Which one do you move down? You don't move either. You don't move any of them down. You don't move any of them down, right? That's why I say I recommend you ignore it. I learned to ignore it, but as you get older, you don't have to because you just know. I recommend you ignore it and pretend it's not there. And then you just count them out in decimal places, right? And then just move them over to the left. How many decimal places in your product? Based on how many decimal places you have. Yeah, I'll give you a couple of examples. All right. I'm not gonna do this one. This one you guys do yourself. This one is easy. You guys know the trick. All right, let's do this one. Okay. Number 3. The largest one. The largest one can go. What do you mean the largest one? Like largest number? Yeah, number 2 is very easy. Don't multiply this out. You guys, do you guys know the trick for number 2? I hope you guys know the trick for number 2. Okay, don't bother writing anything out. You should do this in your head. Okay. You're gonna OO me? Alrighty. Okay, so let's do number 3 example. So you have 89.2. Oh, whoops. I wrote it wrong already. Okay. So notice that 2.234 has more digits than 89.2. So I recommend, you don't have to, I recommend you put on top. What you told me to do was what I did. Not to do was what you did. Okay, so for number 2, you guys know the trick. If you're multiplying by 10, 100, 1,000, blah, 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 10,000, 100,000, you just move the decimal point to the right based on how many zeros there are. Yeah. You just move the decimal point. You don't have to multiply anything out. Same thing goes for dividing. So if you had 1,276 divided by 1,000, right? you move it to the left when you divide based on how many zeros there are. So this would be 1.276. Check that. I thought you guys knew the trick. Okay. It's a very common trick. Okay, let's do number 3 together. I have no clue. I thought you guys would know how to do this. Okay. So 2.234 times 89.2. And so you keep in your head this 1 decimal place plus 3. So for total of 4 decimal places. And you just multiply this out. So 2 times 4 is 8. 2 times 3 is 6. 2 times 2 is 4. 2 times 2 is 4. 9 times 4 is 6. Carry the 3. Put the 3 right here. 9 times 3 is 27. Plus 3 is 30. So 0. Carry the 3 over. 9 times 2 is 18. Plus 3 is 21. So put the 1, carry the 2. 9 times 2 is 18. Plus 2 is 20. So right here. Okay. 8 times 4 is 32. 8 times 3 is 24. Plus 3 is 27. 8 times 2 is 16. Plus 2 is 18. 21. 8 times 2 is 16. Plus 1 is 17. Then you simply add it together. So 8 plus nothing is 8. 6 plus 6 is 2. Carry the 1. 4 plus 2 is 6. Plus 1 is 7. 4 plus 7 is 11. Plus 1 is 12. 8 plus 1 is 9. 2 plus 7 is 9 and 1. And you have 4 decimal places. So you count 1, 2, 3, 4 decimal places. And that is your answer. 199.2728 for number 3. So you just multiply it out like normal. And then you just put the decimal places over. What I do is I place my value like that. I don't know where you got the 239 from 89. It's just 89.2. 89.239. I don't know where you got that from. That's not the question. Oh, did you just do your own question? Okay. That's like your own little problem. You could do that. Just a random number. You could do that, but that makes you could do it, yeah. Well, that makes multiplication a little harder. I recommend you put the number of more digits. So this has 4 digits. This has 3 on top. I think that's right, Jenny. I think that's right. Yeah, that's right. So taking your numbers, I recommend you do 89.239 times 2.456. I recommend you do that. You could do it the other way, but it's just, yeah, that's right, Jenny. But it won't be as clean. Like you could still do it. I don't recommend that. It's a little tip because then it just doesn't look as clean. You can still do it. You can still do it because commutative property of multiplication. So yeah. And you just multiply this out normally. And then so you have 6 decimal places. So make sure at the product, you count 6 places from the right. That should be right, Jenny. Yep, that's right. So yep. Yep. Yeah, 2.5 squared is just 2.5 times 2.5. So this has 2 decimal places. So your answer should have at least 2 decimal places in it. 6.25. That is the random question. They changed the question to that. 80.2 times 2.698. Well, remember what I said. So when it comes to decimals, 80.2 is the same thing as 80.200, right? You can just shave off the zeros in this one and notice that the 2.698, so 2.698 has more digits than 80.2. So 2.698 has 4 digits and 80.2 has 3 digits. So you just put this on the bottom. That's an 8. That's an 8. Come on. And it's the same thing. Just multiply it out. Also include the numbers above the words. Oh, that one? Oh, yeah, that's the same thing. That's a random question. I changed the question to. Oh, I see. Why would you do that, though? Yeah. Why would you do that? You don't have to do that. When you're adding, yeah. When you're adding, you want to add the zeros, yes. When you're adding or subtracting, add the zeros. Because it helps you visualize the things better, the place values. So if you were to add 80.2 plus 2.698, then add the zeros to help you visualize better. Or subtract. Subtracting is, I definitely recommend you add the zeros when you subtract. Zeros are no difference where the decimal is preferred. Yeah. This is the same number. You can add an infinite amount of zeros and it'd be the same exact number. Is it equivalent to each other? That's how decimals work. I thought you guys would know that. So yeah, all right, let's move on. Here are your answers. So like I said, you just move this to the right because you multiply by 1,000. Just move the decimal point over. Yep. All right, you can check your answers right here. I thought you guys knew the trick. I remember every whole number has a decimal point at the end. So if I had 72 times 100, that would be 7,200 because there's technically a decimal point at every whole number because 72.0 is the same thing as 72. And just move it over 2 times, add the 0 there. So yeah, we get this number. How do you do 1, 3, and 4? Not the 1. Well, I did number 3 right here. It's pretty messy, but you just line it up, you multiply it out, then you count the amount of decimal places in your factors. So there's 1, 2, 3 and 2.234, and there's 1 in 89.2. And then you just count from the right, you count 4 decimal places. So 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place, and then you add your decimal. Not a little, a lot. So you add how many numbers there are after decimal number. Yeah, basically. So there's three numbers after the decimal place or decimal point, and there's 1 number after the decimal point. So you just add them up together. So 3 plus 1 is 4. And then you just count how many places to the left in your product. What do I remember, Jenny? Thanks. Okay. All right, let's move on. What do I remember? All right, dividing decimals. This is, I don't know why I wrote 3 different slides for this. The trick is you're an admin. Good for you. Okay. So dividing decimals, they're a little tricky. Is there homework? There shouldn't be. Ask Lero about that. Is there homework, Lero? I don't know. Ask Lero. Lero is in charge of all that. Okay, so dividing decimals is a little tricky. Not really. Okay, so there's 3 types: dividing whole number by decimal, dividing a decimal by a whole number, or a decimal by decimal. So remember, order matters when you're dividing. Actually, it does matter. All you have to do is make the second number into a whole number. So if I had 7.85 divided by 0.5, it would look like that, right? You divide it out. And the trick is you just make this into a whole number, right? So this would be 5 divided by 78.5. And I'll get into that a little bit later. So yeah. So press the division, you have your quotient, which is aka your answer. You have divisor, you have your dividend. Dividend is the thing that's getting divided. Divisor is the thing you're dividing by. And you have remainder. No one does remainders, come on. All right, so to multiply decimals, you multiply the divisor by as many tens, which is basically just move the decimal point as many times as necessary until you get a whole number for your divisor. I know that. Remember to multiply the dividend. You also want to multiply the dividend by the same amount of decimal of tens. So however many decimal places you move your divisor, you want to do the same thing to your dividend. Why? So you keep the equation the same. So if I had 1.6 divided by 3, why not change this decimal to a fraction and multiply the one on the left, one on the right's reciprocal? Well, how would you know what the fraction is instantly? Because I don't know about you, but 75.2316 turned down to a fraction is a pretty big pain in the butt. Like divided by 1.23456. So why not change each decimal to a fraction? Like, how do you know what the fraction is for 0.2356, you know? Assuming that you have that number. That'd be hard, right? Because I mean, you could do 2356 over 1,000 or 10,000, but then it's just not helpful because then you have to simplify. You have to simplify at the end, and usually, when you get decimal answers, they just don't make good fractions like this. Like this is a nasty fraction. Of course you can do that, yeah, but they just don't make good fractions. All right. So whole number by decimal. So when you divide a whole number by decimal, you want to move the decimal point of the divisor, so this number, to the right, so it becomes a whole number. And then you do the same thing to the dividend because you're technically multiplying the whole thing by 10, and it just remains the same. So yeah. Yeah, it is too, yeah. But this is just an example. You could do that, but that's just really messy. I mean, yeah, fractions are better than decimals at the end of the day, but you could do that, but yeah. And then what do you do with the empty space? So if you had the 5 and that, just move it once, you just add a 0. You add zeros to fill in the gaps. So any gaps you have, you add zeros. And so technically, 5 divided by 2.5 is actually 50 divided by 25, which is 2. And that's the same thing for this one. So if I show you out this way, right? So you have your decimal point here. You just move this over 1. Then you don't have to put your decimal point here. So it's 50 divided by 25, just 2. Yeah. So it's essentially the same as multiplying 10 to each number. And it works because why is 10 overrated? Is it overrated? It's really simple. I mean, I like it. I like 10. And it's the same thing because you just multiply both numbers by 10, not 3. 3 is overrated in my opinion. All right, decimal by whole number. It's kind of similar. You just move this over. You move the decimal place of this part, and you just move the decimal place of that part. Really the same thing. So 5, 2.5. No, actually, you don't have to do that. You can just do this. So you can either do this if you like. You can either move it over 1, or you just bring up the decimal point and just divide normally. I'm not going to read this. This is legible. 3 is a good number. Yes, but it's overrated. Okay. And another way, simply ignore the decimal point. Pretend it's 5, and then that's like multiplying because you have one decimal point place right here. Print 50%. I don't know. What do you mean 50%? I know that this is 50%, but okay. And you just find the quotient and you add the decimal point after the quotient. So 25 divided by 5 is 5. But then since you have one decimal place over, you just count 1 there. So it'd be 0.5. All right, decimal by decimal. Same process. I'm not going to read all this. Okay, I should. Okay, so all you just need to do is turn this number into a whole number, right? So you just move this once. Move this decimal place once. And you do the same thing on this one because you want to keep it the same. So you turn 7.85 divided by 0.5 to 78.5 divided by 5, right? And you just divide as normal. So if I show you how to do that on division thingy, just do that, bring the decimal point up here, and just divide as normal. So 1, 2, so this is 28. That would be what? 5? Yeah, 5, 25. You get 35 and then 7. 7 times 5 is 35. So you get 0. You can't, what can I not do? And that would be your answer. 15.7. What can I not do? Turn the 0.5 into a whole number. I can if I do the same thing. Okay. What's it called? Property of equality. Whatever I do to one side, or whatever I do to one part of an equation, I have to do to the other, right? So I multiply the whole thing by 10, just keeps it the same. So I can, if I also change the other number, the dividend, this part, right? If I change this, if I change the divisor, I have to change the dividend, and the other way around. If I change the dividend, I have to change the divisor. If you don't, then it's not the same question anymore. It's not 7.85 divided by 0.5 anymore. It becomes a totally different question. You get not a totally different answer, but you get a different answer. So you can if you keep both balanced. You have to keep the balance, you know? Keep the balance. Why can't you do 785 divided by 5? 50? Wait, what? That's something like inequality? No, inequality is later. Type of for the 5. Which 5? This 50 is 5. Put in 50. Put in 50? Oh. You can do that. That's the same exact thing. That's the same exact thing. That's just, wait. No, you can't do that. Well, it won't give you the same thing because 7.85 divided by 0.5 is not equal. 785 divided by 5. If one number gets a shift, so does the other number. Exactly. Yes, exactly. 50? Oh, 50. Ah. Bro. Type things right next time, okay, Jenny? Like, you're seriously saying you're big brain out here and you can't even type things right? I'm joking. I'm joking. Yeah, this is the same thing. This becomes equal. Same thing, because you move this twice, you move this twice. So it's like inequality. Not really, but if that helps you, sure. Not really though. Bottom line is you want to make this part a whole number. That's it. That's the bottom line. That's the bottom line. Make this divisor the whole number. All right, that's the bottom line. Okay. All right. Let's see which one I'll do with you guys, because I thought you guys would know this already. This is stuff I learned in 3rd grade. All right. Let's do number 3. All right. So you have 7.2 and 3.8. Yeah, that's right. Okay. So remember, make this number, the number outside the division thingy, into a whole number. So you move this once. So then you also move this once. Move the decimal place up and just divide as normal. So 72 cannot go into 38. So this would be a 0 right here. 72 can go into 388. That'd be what? 4 times? No. 72 is approximately 70. This can say it's 400. So 5 times. Yeah, say 5 times. Let's try 5. Yeah, that's perfect. So that's 360. Then subtract as normal. Bring down the 8. Then you have a 288. That should be 4. Because 4 times 2 is 8. And then 4 times 7 is 28. Yeah. And that's how you do it. So your answer is 0.54 for number 3. That's you just make this a whole number. So move this as many times as you need to, whole number. And you make sure you do the same thing for the other number. Round to the nearest hundredths place. Okay, let's do number 1 then. That's not right, Zoe. Number 1. So 6.4. Read directions, Jenny. Read directions. Okay. So let's do number 1 real quick. So you have 6.4, 7.2, right? You're wrong from. Yeah, that's right. I don't think I not rounded number 1, but honestly, whatever. Whoops. Okay. So notice that the 6.4 is not a whole number. So you move this over once. Move this decimal point over once. Do the same thing over here, right? So now you get 72 divided by 64. Then you move your decimal point up. Just bring it up here as your answer. And you just divide as normal. 72 minus 64 would be 8. Then you can bring down a 0. I'm assuming you know how to do that. You can bring down a 0 because infinite amount of zeros. This would be a 1 or 64. That would be 16, I believe, right? Yeah, 16. 16, bring down another 0. That'd be, no, I did that. Yeah. then 2, because, yeah. So 8, 2 times 6 is 12. I'm running out of room, but it's fine. 3, 32, and then bring around the last 0, 30, 20. It'd be 5, because 5 times 4 is 20. So you get a 0 at the end. 5 times 6 is 30, 32. So your answer would be 1.13, because you have to round it. Maybe numbers are too tough. I don't know. Maybe. I mean, I don't see you guys spamming easy anymore and stuff like that. Easy. Easy. All right, let's move on. I have a lot more slides to go. Here are your answers. Pretty sure. I think these are wrong. Whatever. Running out of time, so let's just keep going. All right, order operations. Okay, so parentheses first. Anything inside parentheses goes first. Then you get exponents next. Anything multiplication, any division, that should be fraction. Any addition goes next, and then subtraction. I'm rushing right now. Subtraction. So how I learned it, like I said, I mentioned before, another way to memorize this is please excuse my dear Aunt Sally, or PEMDAS to memorize this, PEMDAS. Now I learned that if you have these two grouped together, so the two operation types show up, addition and subtraction, or multiplication and division, then you do it left to right. So if you have 4 times 3 divided by 6, you do 4 times 3 first, and then you divide by 6. That's how I learned it growing up. What is PE? It's just a thing. Yeah, that's also what you learned? Yeah. But then a lot of other people, what do you do with PEMDAS? This is the order of operations. So if you had, you'll see in a few examples. Yeah, that's how, but a lot of people I met, they do this by heart. So they do multiplication first and then division, which is, this is normal. But if you had 4 divided by 4 times 3, which if you do multiplication first would give you a totally different answer than if you did left to right. Because if you did left to right, this would be 1 times 3. But if you did multiplication first, then this would be 4 divided by 12, which is totally different than 1 times 3. What is exponents? Have you been paying attention? I'm joking. Maybe you weren't here. Exponent is please execute my deadly asparagus soup. An exponent, do I have to go all the way back for this? All right. An exponent is a number that tells us how many times a number called the base is used as a repeated factor. So basically, if I had x to the 4th, this would mean x times itself 4 times as an exponent. And this is your base. So x is your base. Your exponent is the 4. So x to the 4th is equal to x times x times x. This dot also means x. Times, by the way. This dot times x. X times x times x times x. 4 times. That's what that means. So yeah. Okay. Here. So parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. So memorize that. PEMDAS. How do you remember PEMDAS? You can either memorize PEMDAS, 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 or please excuse my dear Aunt Sally, or as Cindy said, please execute my deadly asparagus soup. Please execute my disgusting addictive swan is how you remember it. I've never heard these before. You guys have some interesting mnemonics. I learned PEMDAS, just PEMDAS. Okay, I don't care about dear Aunt Sally. I don't care about your disgusting addictive swan or your deadly asparagus soup. I care about PEMDAS. Hey, whatever floats your boat though. How do you memorize it? It's important that you do memorize. Not really, but yeah, it is important that you memorize. So yes, that's how you memorize it. You memorize these mnemonics. PEMDAS. PEMDAS. Please excuse my dear Aunt Sally. Or however you guys do it these days, man. I don't know. All right. So do some practice. Remember, parentheses first. Brackets is also another way as a bigger parentheses. Parentheses first. You know, I'm going to zoom through this actually. I'll just give you the answers. But like for number 3, you would do 17 times 100 first, and you do 2 minus 1 first, because there's anything in parentheses goes first. So this would be 1,700 plus 4 divided by 1. And then exponents, but since there's no exponents, you can move on. Multiplication, there's no multiplication. Can you please execute my deadly serious dearly is dead? Yeah, you could do that. I don't know, whatever floats your boat, whatever you like. What question number would be 63? I think so. I'll just give you the answers. Yeah, 63. So then this one is 4 divided by 1 is 4. I gotta rush through fast. You can look up problems online. This is honestly simple arithmetic. Very simple. I mean, 5 squared is 25. 5 times 5. This is not that bad. 22 divided by 2 is 11. 2 times 5 is 10. 11 minus 10 is 1. 1 squared. 1 to the any power is always 1. You guys should, because 1 times 1 times 1 times 1 is 1. So yeah, let's move on. What about GEMDAS? Grouping exponents, multiplication, division, subtraction. Gosh, Emily, my dog ate Sally. First of all, Emily, your dog needs help. Second of all, I've never heard of grouping, but yeah, grouping, I mean, that works too. Just be careful, because then you can arbitrarily group, and then you just mess up your entire problem. So that works. I learned parentheses. All right, divisibility rules. So this is to, yep, that's right. 1 to that power is still 1. I mean, think about it. You're multiplying 1 infinitely, you just always get 1. Okay, so to help you get GCF or LCM, like yesterday's lesson, via prime factorization a little faster, you can use divisibility rules. I think you guys know divisibility rules. So we see the conditions for whether a number is divisible by 2, 3, 4, 5, 6, 7, or not 7, 6, 9, or 10. 1 to the infinity is still 1. As far as I am concerned, yes. So to define divisible, number A is divisible by number B, that is not 0, because you can't divide by 0, remember? If the quotient is an integer, so B must divide into A evenly. So basically, this has to equal C, where C is integer. That defines divisibility. Okay. 2, all even numbers are divisible by 2. And just look at the ones place, see if it's a multiple of 2. There is, yeah, but I'm not gonna teach you guys it. You can look it up yourself. Should be easy to memorize. All these numbers are divisible by 2, even this one, this big number, because it's 0. All divisible by 2. Every even number. All right, 3. C of number is divisible by 3. You add up the sum of all the digits of a number and see if the sum is divisible by 3 itself. So for example, it's 2,502 divisible by 3. Well, 2 plus 5, actually. Okay, take sum of the digits, 2 plus 5 plus 0 plus 2 would be 9, right? Because 2 plus 5 is 7, plus 2 is 9. And since 9 is divisible by 3, 2,502 is divisible by 3. You can check that yourself. So it's 1, 2, 3, 4, 1,234 divisible by 3. Well, take the sum. 1 plus 2 plus 3 plus 4 is 10. And since 10 is not divisible by 3, 1,234 is not divisible by 3. Yep. So 3, add up all the digits. 4. A number formed by the last 2 digits of a number is divisible by 4, then the number itself is divisible by 4. So and also keep in mind, every multiple of 100 is multiple of 4. So obviously 300 is divisible by 4. 400 is divisible by 4. All that good jazz. Last 2 digits is divisible. Yeah, I think it is, yeah. Of course, sorry. Yep, that is not divisible by 2. So 312, 528, 1,024. You can either look at the last 2 digits, which are all divisible by 4, because 12 is divisible by 4, 28 is divisible by 4, 24 is divisible by 4. Or you can split it up, either 300, 500, 1,000, all of which are multiples of 100, and they're all divisible by 4, and you can see what's left right here. All right, 5. Number ends with 0 or 5. Yeah, that's true, sorry. Number ends with 0 or 5, the number is divisible by 5. And all multiples of 10, 100, 1,000, etc. divisible by 5. So 1,000, 2,500, 3001 is not divisible by 5 because it does not end in a 0 or 5. I won't say please if you don't. Please execute my disgusting addictive swan. Do we have, I don't think so, Donald. I don't think so. All right, so for 6, see if the number is divisible by 6. If number is divisible by 2 and 3, then it's divisible by 6. That's because 2 times 3 is 6. And since 2 and 3 are factors, that makes it divisible. So 252. 2 plus 5 plus 2 is 9. So 252 is divisible by 3. 252 is also an even number, so divisible by 2. So it's also divisible by 6. I'm not, no. I'm not doing Kahoot or a quiz with a double Z today. All right, 9. See if number is divisible by 9. Same thing as 3, except it's a little different. See if it's divisible by 9. Actually, it's the same thing. Just same thing. So you add up the sum of all your digits and see if it's divisible by 9. So 765, well, obviously, because I put that in an example, 18 is divisible by 9. So 765 is divisible by 9. Now, is it divisible by 3? Well, yeah, I mean, 18 is divisible by 3, but doesn't apply to all numbers. So you can conclude that anything divisible by 9 is divisible by 3, because 9 is a multiple of 3. But anything divisible by 3 doesn't automatically mean it's divisible by 9. So the rule doesn't cut backwards. Keep that in mind. All right, 10. Anything with ending in 0 is divisible by 10. So easy to remember. Is this number divisible by 10? This is this ridiculously big number, which you can just ignore. Just ignore. 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 Oh, look, ends with a 0. Well, there you go. Yes. Good job, class. Good job. All right. All right, so composite numbers. Recall that a prime number is a number. It's only one factor. Or factors as 1 as the number itself. That's a prime number. Look at the pictures of that. Then why are you here for one? What the heck? What? Wait, you shouldn't be here then. I'm not gonna wait. Pre-algebra is miles ahead of this. Not miles, but pre-algebra is ahead of this. Huh.
It's also class.
Yeah, but why are you in this class then? This class is different than pre-algebra. Okay. Composite number is a
because my mom got me these two class.
Oh. Okay, pre-algebra it's not miles ahead, but it is somewhat ahead. It's different.
It starts at 6 o'clock p.m.
Okay. Wait, never mind. Is number divisible by 10? Yes, it is. I will be done soon. Oh. All right, so a few questions. How many even prime numbers are there? Well, think about it. Only one. 2 is the only prime number, right? Because there's only one. So, because every even number is composite, because every even number is divisible by 2. Now, is every odd number a prime number? Well, obviously not, because there are numbers like 9, numbers like 15, 27. Those are odd. 21, yeah. And then all prime numbers besides 2, odd. Think about that. Yeah. Yeah, every prime number besides 2 has to be odd, because if every even number is odd, every even number is odd. What? If every even number is composite, then all primes have to be odd besides 2. And what makes a number odd and number even? So yeah, what do you guys think? What I'm trying to lead you here is a sequence, but you don't need that. You don't need to know that until like a couple years down the line. You don't know? Well, the easy definition of an even number is a number divisible by 2. Or you can also write it as 2n, where n is any integer. It could be even any real number, I think. So an even number can be written as 2n, where you can plug in n for anything, and it should be even, as far as I know. And an odd number can be 2n simply plus 1. And that makes sense, right? Because if you plug in 0 for n, then this is 1. This becomes 1, which is an odd number. And 0 is technically both, but 2 times 0, 2 times 0. Technically both even and odd, but in this case, even. Because 0 divided by 2 is divisible. But if you had put 2 for n, this would become 4, and this would become 5. And 5 is odd. So yeah, 2n plus 1, where n is anything, is odd. All right, just for fun, here are the prime numbers from 1 to 100. They say that you should memorize these, which I recommend you do, but you don't have to. Look this up on Google. Notice that they're all odd. 3, 5, 7, except for 2, 11, 13, 17. Why is 1 neither? One's special, because 1, its only factor is 1, but then you have like infinite amount of factors. 1, 1, 1, 1, 1, 1, 1. 1 times 1 times 1 times 1 times 1 is all 1, right? So 1 is a little special because 1 in itself, but then you can put that as many times as you want. As the numbers go larger, the rarer primes get. Yeah, that's true. Yeah. You can see that this last row right here. So 2 is the only even prime number. Yeah, as far as I know, yeah. Because every even number besides 2 is composite. All right, you guys are free to go. You don't have to do this. Because we don't have enough time. So you guys are free to go. But this is just to help you prime factorize, because 55, well, 11, but you can see that, let's see, 8 times 7, 17 now. You can see that this is divisible by 3, and this is also divisible by 9 straight off the bat, right? So it helps you prime factorize it. But you guys are free to go. Maybe these lessons are long. Next week is going to be like basic algebra. You guys already know that. Ew. Basic algebra. You can go sleep. All right, good night. Good night, East Coast. You guys sleep so early. Little kids, I tell you. All right, any questions? Stick around. If not, I just end the class. So, any questions? Yes, because it's 9. I'm not going to tell you what time I sleep, but yeah. Goodbye. If I told you guys, it'd be bad. You go to bed at 11? How old are you, Cindy? I'm not gonna lie. At least it's computer classroom for algebra. So why are you here? Why are you guys here then? This is 6th grade math. Algebra is ahead of that, like a lot. Like at least a year and a half. That's what I'm confused about. People in pre-algebra. That's so confusing. What? All right. If you don't have any questions.
What grade is for pre-algebra?
Well, let me think. Should be 8th grade. Should be. Because you take algebra in 9th grade. But it could also be 7th grade if you're advanced. But the default grade is 8th grade. But this is 6th grade math. But this is even 6th grade math. It's more like 4th to 5th, if I'm going to be honest. So yeah, should be 7th to 8th for pre-algebra. This is like 4th to 5th, even 3rd. I dare say 3rd. 3rd grade, you learn all this stuff too. Some of this stuff. So
Okay, thank you.
Yeah. So I don't know why you guys are here. I'm not gonna lie. Because pre-algebra, you learn same exact things, but better. Because it's more expanded. All right. Any other questions? No? All right. I'm just in the meeting. I'll see you guys next week. Make sure you guys are staying hydrated, staying safe, staying healthy. I'll see you guys next week. Bye-bye.